Hello, my name is David, and my research is on the electro-dewatering of mature fine tailings from oil sands. But what are tailings? Tailings are a fine suspension of hydrocarbons, clay, and silica particles in predominantly water. And we have around 1.5 billion meters cubed of tailings inventory from the oil and gas industry in Alberta. This is around the same as 1 year's worth of the water flow in the Bow River. And tailings are a problem because they're able to get into places they're not supposed to be, groundwater and runoff, and they are toxic due to residual hydrocarbons and trace amounts of heavy metals found in them. What can be done to treat them is something known as dewatering, where by removing the water from the tailings, you reduce the volume for one, and second, make it less mobile and effectively turn it into dirt. The electro-dewatering technique is done by the application of an electric field through electrodes where the water is drawn to the cathode and thereby removed from the tailings. Now, the objective of this research is one, to develop a in situ method for electro-dewatering, meaning that you don't need to transport the tailings from the pond to a facility to treat it, and to make that electro-dewatering process more efficient. You can see we were testing electrode configurations and kinetics to see where the middle ground is. Here are some constants that were stable throughout all of the experiments. Volume of tailings, power source, location done, things like that. Here are the electrode configurations used. On the left side, the rod and toe. On the right side, three of the vertical rod setup. And in the top right corner, you can see the container used for the tailings, a glass fish tank. For the rod and toe setup, the disc that you see is in fact the cathode. Now for the geometry tests, here were the results from initial to final water content by mass fraction, and the power used to do those experiments for 120 hours you can see on the right. Here's a picture of what the initial sample would look like, and here is the final results for those specific experiments. You can see a water separation at the top. That is important. And some conclusions. There's a large water content disparity due to experiment 2, the vertical rods not being mixed adequately. However, there is such a large performance and power disparity that the rod and toe setup performed better. And the reason why is because water, being the lightest element in tailings, wants to go to the surface. If you place the cathode, the electrode that it's attracted to, at the surface, that will accelerate the process. The power units you saw before were kilowatt hours per dry ton. Here are the results for the kinetics test. You can see the trend lines for 10, 20, and 30 volts over the 15, 24, 48, and 120 hour experiments. And you can see on the right side, again, the power usages for these experiments. You can also see in these images pictures from the 20 volt experiments for 15, 24, and 120, 48 and 120 hours. So you can see the differing water layers separated, which was often an indication of how successful the experiment was. Some conclusions for this and some next steps for the project on the whole. Increasing the voltage did improve dewatering from 10 to 20 volts, but not from 20 to 30 volts, implying that at least on the lab scale, there's a limit to an effective voltage past which you're just wasting power. All experiments that ran past 48 hours also had diminishing returns, where you're just using power for no additional return. And this was likely due to a pressure gradient forming in the tailings that caused the water to want to go back into the tailings rather than being drawn out by the voltage. Some future experiments that can be done are on scaling, likely shrinking the electrode setup to simulate a larger pond, multiple setups within the same container to see if there's any interference between them, and shear strength testing on the treated tailing samples, as that is how it is determined whether or not it is reintroducible into the environment, so we can see if the experiment was genuinely successful. Here were some of the takeaways that I had throughout my summer researching this. It was an awesome time, and I greatly recommend it to anyone who's interested. Thank you very much for listening.